Number 26 says that we deposit $2,000 in a savings account. We get back 4% of that every year. We are not taking any money in or out of the account. Part A wants to know how much will be in the account after 3 years. So we're just adding at an annual rate of 4%. So we have a basic y equals AB to the x exponential equation. A is our y-intercept, or our starting amount, which is $2,000. B is the growth factor. If it is growing at 4%, right now I have 100%, keeping that 100%, and I'm adding 4% to that. So every year I'm going to have 104% of what I had the previous year, which as a decimal is 1.04. X would be the number of times that it grows. So there's our model, y equals 2,000 times 1.04 to the x. In part A, we simply need to plug in 3 for our x. After 3 years, we will have added 3 or 4% 3 times. So we've got 2,000 times 1.04 to the third. So in part A, I have $2,249.73. Part B, we're doing the same thing, but we are plugging 18 in for our x instead. $4,051.63. Part C asks, how many years will it take for the account to contain $2,500? So in part C, we want our final amount to be $2,500. So I'm going to plug 2,500 in for my y. And we want to solve for x. We have x up in our exponent. We have not yet talked about how to solve an exponential equation when we have that x in the exponent, but we do have a couple options available to us. The first, which we'll do here in part C, is to just guess and check. After 3 years, we had $2,200. So it's going to be a little more than 3, but not a crazy amount more than 3. Maybe try 6. So there it is. So 6 was $2,500. Check to see if 5 was above or below $2,500. So after 5 years, we had $2,400. After 6 years, we had $2,530. So it takes 6 years to reach $2,500. So you could guess and check at it. That's a fine way. For now, we'll have a better method soon enough. Another way we could do it, let's do that in part D. If we plug 3,000 in for our y, we know how to solve equations by graphing. So to solve by graphing, the equation always needs to be equal to 0. So subtract 3,000 from both sides. So I get 2,000 times 1.04 to the x minus 3,000. Go to y equals and graph the equation. 2,000 times 1.04 to the x minus 3,000. I'm going to zoom back into our standard -10 to +10 graph. And we are looking for when it crosses the x-axis. We want to know when is y equal to 0. Which looks like it does not happen in between 0 and 10 at least. So it looks like it's going to take longer than 10 years. So let's change our window so it goes out further than just 10. I'm going to change it to 20. Again, we're looking for when it crosses the x-axis. There it is right there. So to find the x-intercept, we're going to calculate second trace, the zeros, which is number 2. And that x-intercept Looks like it's around 10 or 11 in that range. I know it's definitely between 0 and 20. So left bound 0, right bound 20. I don't need to worry about my guess because there's only one x-intercept in there. And we get 10.338 years. But remember, we're only getting interest at the end of the year every year. So after 10 years, we will not have reached $3,000. So it's going to take 11 years to reach at least $3,000.